Hey, I was going to say, this is something completely different. It's so different, we need a different hardware just to make it actually work. So, okay, let's see if this is going to work for real. All right, so this is a talk on Postgres 18, and it's about demos. So we saw some earlier talks on Postgres 18 and features that were out. And for me, the way that I learn best, or that I've always found works better for me, is if I can actually get hands-on, right, see examples, run SQL inside the database, and then see what happens in the behavior. And that's how I learn. So I started doing these kinds of demo talks. They're sort of as basic as they can be so that I could do them anywhere if I need to. I just need a Postgres that runs a PSQL and a very long HDMI cord. And then I can actually do it. So this is the talk. I've gone through and I actually marked some of these features. So I'm not going to cover them because I saw them in earlier talks today. But this script is publicly available. If it's a gist on GitHub, or I can send it to the organizers, maybe they can post it. So you can actually download this whole script and you can run the examples. And what this does is it allows us to sort of change SQL as we're going along if we want to try something, do an experiment or something like that. I use this thing, so you need a Postgres 18. I use this sample database. If you've never seen it, it's also out on GitHub called Pagila. And it's basically like Netflix or like Prime Video, streaming movies, except through the mail, like physical disks. So in case anyone has ever used something like that, it seems like most people don't use that anymore. Okay, so let's go in and we'll do a demo and you'll see how this is all going to come together. So as I mentioned, I've got sort of this table of contents, and you can sort of see different examples that are in there. Like, so the first one is UUID v7, and again, that was talked about at least once today already, and maybe a second time. So I'm skipping that, and I'm just going to jump down to the demos for themselves. And there's a bunch of other ones in there, and again, feel free to download and play. If as I'm going along, want me to like change an example or something, feel free to yell that out, I suppose, and I'll see if I can change that. But I'll mention that in the script, I put the links to the Git commits. So if you want to actually dive even deeper into a particular feature, you have the link there, so you can go look at the commit and see exactly what was put in when they put the release in. So some of them have multiple commits to them, but by and large, that works pretty well. So, all right, let's run the first thing, and we'll just sort of see. So this first feature is called casefold, and there's an existing contrib module. I don't know how many people actually use it, but it's designed to allow you to sort of do like uppercase, lowercase match for text. And it's a little bit clunky. I mean, it was good at the time, so I shouldn't say it's bad. But we now sort of have some better features built into Postgres, and there's some better ways to do that now. So this thing, it's just a very simple example, right, where we're looking at trying to select a title from our film table, and we want the lower title to equal lower Academy Dinosaur, right, and it's all in uppercase. So you can see, like, we use the lower function, makes lowercase for both of these, and that gives it. So that's sort of the old way, but now we have this new casefold function. And the reason that casefold is sort of useful is it follows actual like encoding and character type and language rules. So if you have different languages, like Swedish is a pretty good example, Turkish is another good one, where they have sort of different rules from most languages on how like a lowercase I versus an uppercase I, things like that. You can just use the casefold function and it kind of does the right thing. So in this case, I say casefold title, and it matches, to equal casefold for the title I'm passing in. The actual data in the database is uppercase, but using casefold, it does the right thing. Before, I kind of had to know that everything is lower, and I have to force it to lower. With casefold, it'll do the right thing, and if you have an encoding that does something, interesting with your letters, casefold can handle that as well, whereas lower probably would give you the wrong answer. So this is sort of a better way to do that type of a match if you're doing these sort of different case matches. So that was casefold that's been added in 18. Here's a sort of a more complicated example. So, and as you can see, like I don't actually know what these words are because they're in a different language than I speak. And I speak a couple of languages, not that well. But this is the kind of thing where, so you can see, and I saw Bruce do this earlier, so I have to run up to the screen. So, if you look closely, those are not necessarily all the same match, and we can see that if we call it with lower or we call it with casefold, like it gives you the same information. So, and that's what I mean, like these are, if you get kind of languages like this, where it's, you know, I don't actually know the rules of these languages, and you don't have to now if you use casefold, right? If you don't use casefold, you have to know a lower or an upper will match lower, upper in any language. Casefold, again, casefold kind of makes that all go away, so you don't have to think about it. Again, we can run this example down here. Whoop. Where I'm going to test if the casefold of these match versus if the lower of these match. Maybe they will. Nope, neither of them match. So, okay. Shows what I know. So again, like we're using the casefold version, and I know I'm kind of hammering it home, but we just replace lower or upper. I've seen both ways used. And again, like sometimes in some languages that doesn't actually work out. So if you're collecting like email addresses or names from people, and if you're doing it, you know, on a global sort of scale, casefold ends up being a much better match. And performance-wise, like it's faster, and you know, there's all those kinds of things as well. So, but it is a good replacement starting in Postgres 18. All right, time in vacuum. It's been mentioned more than once at this conference already. Vacuum is where a lot of people spend a lot of their time. And now we've added some extra information into Postgres 18 so you can see more about what Postgres is doing. Now, I actually just started this system, so I suspect I'm going to get all zeros because, of course, that's how demos work, right? So I've not actually done that, but I will vacuum. Let me vacuum one of these. Let's go with country, which shouldn't really do anything, but so I vacuumed it, and let's see if, yes, so I now get 3 milliseconds. So you can see how quick that vacuum was that I ran on country, right? Here's where I ran the command, and now total vacuum time on country shows up in this particular view. So this has been added into pgstat all tables, right? You may have used that for like number of inserts and updates and deletes. So now they've added a bunch of things for like total time in vacuum, in auto vacuum, how much time you spend in analyze, and other information like that. So you can imagine on a running system, right, you go in and you look at this like once a week or something, and you can suddenly see, and maybe you actually would put an alert on this. Certainly if I had like an AI or something, I would just like take snapshots and send it and say, go analyze. And if suddenly some table is spending a lot of time in vacuum that it, you know, like 20% more vacuum time than it used to, please let me know so I can go see what's going on. Before, you could probably do this if you were, I don't know how you would do this. You probably could do this some way with an external system and capturing information. I think you had to actually dump the information into like a log file and parse it or whatever. So this makes a very simple way. You just do a query and you can see how much time, right, you spent in vacuum. And if I vacuum it a few more times, of course, that number will go up. It doesn't go, right, it took less time for those subsequent vacuums because now it's been vacuumed, so it's even less time. Another thing we can see with vacuum, a feature that's been added in, we have to set a couple of gucks here. So show track cost delay timing. If we want to see how much time is being spent for cost delays, if you've ever used cost delay feature, it sort of slows vacuum down so it doesn't take up too much I/O. So here, normally this is off. I'm going to actually turn it on. The default is off, but you can turn it on in 18. So that is now running, and now I'm going to do a vacuum verbose. And the important thing here is our delay time, which is right there. So I don't actually have any cost parameter set, so I have no delays on this. If you run with cost delays on your system, this is the line that will show up. And again, if you don't have 18 right on an older version, I think it's actually no way to see this information, short of, you know, attaching with a debugger, I don't know, like something crazy like that. So this is another one where they've added this into your vacuum. So you can see like, hey, if my vacuums are taking a very long time, one of the things you want to look at is maybe you have too much delay in the system, too much cost delay, and that's slowing your vacuums down more than you need to. Certainly one thing to do would be to compare total vacuum time to the amount of delay time. I don't think, 18 is still new. I assume nobody here is actually running 18 in production, but maybe some of you are more ambitious and actually do run it. I don't know if we've come up with like what's a good ratio of time you should be spending with delay time yet. That'll be something we'll have to watch in the community and see what we get out of that. But at least being able to see the information is always the first step, right, and being able to act on it. Let me do another query here. You can see, I think this will give us, right, so I got nothing back on this, so delay time, because I ran that vacuum, but I don't have any cost delays, right, so that it's all super fast. There was no delay time, you saw that up there. So now I can set some delays. So now I'm setting down here, right, you see set vacuum cost delay equal to 100. I'm going to set the vacuum cost limit equal to 1, which basically means like if your vacuum is going along, this still, again, it's a small system, freshly started, probably not, a lot of stuff for it to vacuum, but let's see if we can actually get a different number. Anything is possible. Oh, it did take a little bit longer. Oh, look at that. So you can see, right, so now I've actually set my delay time. Because I was actually adding like this cost delay of 100, so that's like 100 milliseconds that I'm saying, when you go to run vacuum, right, if you start doing those I/O operations, I need you to put these little bits of delay into my vacuum process so it doesn't overwhelm things. And I set a limit on that, so you can actually see that the number does correlate, right? I set the cost vacuum delay to 1, I run my vacuum, and I'm just under where that limit would be. So again, this is the kind of thing where some people use this feature a lot. They're setting these all over the place. By default, there is a delay, I think, in earlier versions. So that may be worth looking at once you get upgraded, and just check those settings on your system. That may actually be like cloud provider dependent, but it's worth a look to see if that's something that you're working with. All right, another sort of different direction, but also still vacuum related. There's a new setting called vacuum truncate, and I'll just kind of run that. So what this does, and this is sort of a feature that now can be set sort of globally, and there's been sort of ways to try to work through this before. So for those that aren't aware, normally when vacuum runs, and we're just talking like a regular vacuum, right? It goes and it cleans up the table and it marks rows for reuse. But at the end of the vacuum process, there's a little bit of time where it actually goes to truncate the file. So if you have empty pages at the end of your table, it actually takes a lock sort of at the physical level underneath the system. So not like a heavy lock that you'd see in the database, but at the file system level, it takes like a little lock there, and then it removes those files off of the file system. So maybe that's good. I actually think it's not actually that useful, because you're probably going to end up recreating that file relatively soon for new data, after you've just run a vacuum and you clean things up. But by default, that is what happens, right? It tries to remove that file if it can. The problem is, like, every now and then we see like these weird, they're not bugs because it's how the system is designed, but we see these weird side effects where, let's say the vacuum goes to grab that lock to remove the page, and it doesn't often do that. That's one of the reasons why these things are a little bit rare. But if you have like a replication going, and maybe there's a query running on the replica that's actually looking at that same table, right? And it might actually be trying to read data from the end of the files, where vacuum is going to say, hey, this is all cleaned up and could be removed. It can't remove it until the replica is done with its query. And the problem is, because it's taking this lock at the file system layer, that can actually block other operations in the primary. So that tends to be very bad behavior. And if you see it, like, it's hard to deduce, because it comes across, you're like, something's going on over here on a replica, and then the problem surfaces on the master, and it looks like an outage because queries pile up, and it's kind of a problem. But we didn't have a way to actually stop it from doing that behavior. And so what this does is allow you to set that globally, right? And you can just say, look, on my system, I don't need to worry about removing these pages off the end. They will get reused eventually anyways, so it's fine if it doesn't actually get, removed from the file system. So that sort of helps avoid some of these sort of rare problems. But if you've ever seen something like that where you're like, I don't understand why it looked like it locked up for a second, and you have replicas and queries going on, like it could have been something like that. And for me, like I will probably start making this default to off so it never does that truncate. That sort of maybe early advice that may not be proven to be true yet, but you know, that's sort of where I'm thinking that's going to end up. So that's a new feature as a GUC, and you can actually set that per table, so you don't have to set it globally. If there are particular tables that you were worried about with that, from a replication standpoint, you can set it per table. All right, PSQL extended view. So I have a bunch of different new ways to look at data, I guess we'll put it that way. Through PSQL. Out of curiosity, I use PSQL actually for my primary interface to Postgres. I'm curious if that's like everybody uses PSQL, I assume, right? Hopefully. There are other things out there. I suppose now everyone will just vibe code a new interface and then they'll use that instead, but I still use that. So I have this function in the database. It is called rewards report, and it basically gives out, so again, in this sample database, it's like films and people rent films and then, right, you can earn rewards and stuff like that in there. So we're doing a situation where we have the function that allows you to pull the rewards for people. So this is actually, it's a little bit hard to see here. Hold on a second. Let me run the next version. So the first one is running \dfx. If we run it this way, it's a little bit easier to see. And this shows us our list of functions. So the key sort of difference here, one of these bits is, this is actually a procedure in the database. So Postgres, you know, sort of has this legacy of, it had functions before it had stored procedures, and then it implemented stored procedures, and sometimes these things get a little bit mixed up. And so here we can actually see the stored procedures in there, and we try to make this a little bit easier to read, you know, with wrapping and whatnot. So they're trying to do improvements, even in PSQL, which has been around, you know, since basically the start of Postgres. There are still things that we're trying to show. Over here, I have a thing called a rental report. You can see so this is a view called rental report, and if you want to see the SQL of the view, sorry. So this is a report that basically just shows a big bunch of JSON, right, data that it pulls from other tables. All right, so we have, so if we do \dv, right, that's to show a view, and then I pass in the name of the view. So that's rental report. And let me show you the new sort of hotness, which is this /dvx, which again, like just sort of reformats it in a different way. So we've sort of expanded that, that \x, for people who aren't aware, right, it changes whether the display is vertical or horizontal. And you can actually set that auto, and it tries to do the right thing. But there are certain commands where it's more likely that that will be useful than others. And like functions is a good one, views is another one, because they can have, you know, sort of larger pieces of text that are involved there. Let's see here. Per backend stats was talked about earlier today, so I'm going to skip that one. Let's talk about get ACL. One of the things, and this is admittedly a complicated example, I actually tried to, because everything's about AI these days, I tried to get AI to write this talk for me. So I've been doing this for years, like since before there was AI, right? And I tried to get AI to write this talk for me a few months ago. And what I found was like all the examples are super complicated, and sometimes the answers were hallucinated, and sometimes it was like the feature wasn't actually in 18. So, you know, like that's not a great example for an 18 demos talk. So a lot of this is, I wouldn't say that there's no AI involvement in writing this talk. I hope when I do the 19 version, there will be a lot more AI involvement and a lot less of my involvement. But for now, most of these are fairly handcrafted. But this one actually stays pretty complicated because the nature of what we were trying to do ends up being complicated. And I don't know how much people need to do this normally, but if you ever had this problem, like it was a nightmare to solve, and now it's just complicated. So I look at that as an improvement. So what we're trying to do is actually find out the permissions of users within the system. And if you know anything about roles, you know that you can inherit from this person over here, and you can be a member of that group over there, and roles can be very complicated. And the permissions are all different, right, depending on the object. So if you have a table, it's, you can select from a table and update. If it's a function, you execute the function. If it's a sequence, like remember, there's a long period of time where people would always forget to grant permissions on the sequence, and then they try to insert in the table, and you get an error because you didn't have access to the sequence and all that stuff. So we're going to kind of walk through building this out. So make two roles in the database. One will be for an analyst, and one will be for a manager. You can guess which one is going to do more work. I don't know, maybe that's tough. Analyst maybe doesn't do a lot. Okay, so then I'm going to grant select on the customer table to the analyst, and I'll just sort of walk through these. So I'm grant select on the customer, so selecting on one table. I'm getting the manager write operations, right? So they're going to get select on the next line. They'll get insert update on customer, and because the analyst only needs to read the data, right? Like the manager in theory needs to be able to do whatever is necessary. We'll do the same thing on a rental table. I don't know if we picked up on this. Hold on. So if you want to see, like, here's the schema of the data, right? Actor, address, city, country, customer, films, right? Just a bunch of tables like that. Okay, so I'm going to grant select on the rental table to the analyst. And again, it's just following that pattern. Analysts get read-only access. Manager gets write access. But then on this function, right, I'm going to grant execute on the function, which is get customer balance to the analyst. And the function is basically like getting what does the customer owe us in money, right? So the analyst is going to look at our data, look at the movies, and look at the customers to decide how much money do they use. And then I've got to grant usage on the schema for both of these folks. So let me run all these grant commands. I don't think we'll get any errors, but you never know. Okay, so those all were granted. There you go. I just mentioned Grant's name like 10 times in this presentation, so he should be happy. So, all right, so then we'll do, now here's the magical query that, like I said, this is a very complicated query out there, but like this is the easy version of this problem. If I said I need to see all of the permissions that I've just done, right, across like whatever the object is, if it's, a function, a view, a table, whatever, I now actually have the capability to do that, mostly with this piece of the query here, PG identify object, which I can now pass in like an internal representation that Postgres knows and say, hey, what is this object that that this number represents? And then I use the new function, which is PG get ACL, which says whatever the permissions are for that object. I don't have to know what the permissions are, just whatever they are, go grab them and show them to me. Right? And then I'm sort of joining on the database because I have to be in the current database to see what I'm doing. That is this part here. And then auth ID is sort of under the hood where we store roles and some of their permissions. So let me run that, and you'll see this output. And it's a little bit hard to read, but let me expand this and see how far I can break the screen. Okay. So if I just sort of lean over to the side here, you can see it a little better. So if you're going to look on the very far corner here on the left, right, you see the type column. And so we've got functions and schemas and tables all in the same column. So I can pull all the results back for any particular object in the database at the same time. So again, before you couldn't do that. You have to like go get all the table permissions, go get all the function permissions, right, and on down through the list. So it's very painful. You can see the identity of the object that's in question. We know the name of the thing, and then probably the most important bit, which is that end over there, where we talk about we're in the database, and we can see PG database owner, and there's a bunch of different ones that are in there. So those are all permissions, and again, they're different depending on what your role is or what your job is, but also depending on what that's probably about right. Also depending on what the object is. So just as an example, if you look right here, so we have that ARW represents append and read and write on the object, on the customer table. And so that's because that's the manager, right? So the manager gets all of that. And somewhere in one of these lines, if you could find the analyst, you would see that he only has read. So this is one of those, like, I'm not sure how many people actually need to do this, but I do think I've run across a lot of DBAs who are trying to do like security audits, and it was just so painful to try to get this information back that, like you would eventually write something that would do it, but now there's an easy way to do it. So I think people will ultimately start using this feature, and it's one that they didn't know they needed or that they could have. I first ran into this problem because I've done work on like GUI tools where you had to actually show permissions and what has been granted. So if you're building any kind of GUI tool that has to manage permissions, again, this will make that much easier. So, and that the main function there was pggetACL is the thing to remember. So if you want to look it up, that's the thing. All right, toast my index. So I don't know how many of you are using this yet or don't know you're using it. But everybody familiar with toast on some level, right? So toast is the sort of Postgres internal mechanism for doing out of the heap storage when you have like very large objects. And we see this more, so if you're storing like JSON objects is probably one of the best examples, but very large text was sort of the original idea. Now JSON objects are a big one. If you're storing vector data, that's another one, where the size of the data in the column itself is often too big for Postgres to store in the main file with the heap and the rest of the data. So it stores it out of line in a separate table. The query that I've written here is just sort of to show that we can look up toast ID, we can look up which objects have toast tables and which ones don't. And we've added the ability to have toast tables for indexes. So one of the problems prior to Postgres 18 was if you had these very large JSON B objects primarily, but JSON objects in general, or very large vector data, right, that you were fitting a column, it might actually fit in your table because the table had a toast capability, right? It could store those very large fields out of band. But the indexing actually couldn't do that. So without the index's ability to do that, like it wasn't that useful because you probably want to actually index that data so you can query on it. And so we've sort of added that capability so you can see that we've added toast tables. Now we haven't done this for everything. So like PG attribute, we sort of decided we don't think we need a toast table for that. For PG class is sort of, again, same thing. We don't need it for that. But for PG index, we've added it. And for PG proc, obviously you can have very long stored procedures. And so maybe you would need to have some toast action going on there as well. So that one's kind of under the hood. You might not notice it, but again, if you start getting into large vector stuff, and as with everything, the more AI workloads come into Postgres, large JSONB and large vectors are certainly the things that are kind of pushing the boundaries on that. We've added some helper functions for CRC32. I'll run through these ones pretty quick. It kind of does what you probably would think that it would do, right? It's just calculates CRC32s faster. Here we're calculating the CRC32 of different movie titles in the database, right? And you have to actually pass in some encoding information in that because you could actually get different answers. Now I can actually create a new column on this. So this is mostly for example purposes, but I'm going to add on the film table a new column called description CRC32, and I want to save that. And that ends up being a big int field on the table. And I can do this as a generated column, right? Because we know it's basically deterministic. Whatever the movie title is, it should generate the same thing every time. And we're going to actually store that data. And then I can actually index the data if I want to, now that I've got it stored. Which I think is new in 17, was the ability to store those generated columns. So bonus note if you haven't done that. And now I can actually query based on those CRC32s. And the reason you might want to do this, so the reason I picked this text column, so obviously if you are searching on large pieces of text, that can be slow, right? Because it's text. And it doesn't index particularly well. If you take those pieces of text and you create this CRC32, you're now basically searching over an index big int field, so much faster to do that kind of a thing. And like in this particular query, like the thing that I'm actually querying, right, is this super long, movie description that's in here, the unbelievable panorama of a composer and a butler, first in the first manned space mission. So as we have started, apparently we're doing space things now again in the world, like we send people to the moon and stuff. So I thought that was kind of interesting to find that one in there. But obviously, if you're just going to search that text string across a bunch of text strings, even if you index those text strings, like that match is going to take a while. So again, CSV32 would be a much faster way to do that. So I think people used to do hash text was a function in Postgres. If you've ever used hash text, like this is a sort of better, faster way of doing that. So certainly that would be like an obvious use case for like, maybe I want to jump in there. The section, I kind of love this as a feature. Again, you're probably going to say, I'm not sure that's actually useful, but maybe it is. So we actually now have, so there's there's a function that was already in there called toNumber. And what it does is it takes text and it turns it into numbers, right? And so what we've actually added was Roman numeral support for the toNumber function, which again, I think my favorite part is because I do this demo talk, and so then I get to talk about it because I just think it's kind of silly, but it definitely understands. So I don't know how many people here actually know Roman numerals, like if you know them pretty well. It is all correct. Like XVIII is, sort of in Latin, if you wrote that down, like that would be 18. That is what that means. And so like I put the name of what they were, right, in as the alias for each column. So in case you don't know Roman numerals, but you're passing in this little quoted RN, right? So you're telling the toNumber function, like, here's a bunch of letters, and I'm passing in to tell you these are Roman numerals. Please convert them appropriately. And I have heard stories where like people's systems break because they were storing numbers in like, a small int field or something like that, and then they don't understand what happened, and you go back and look, and it was like, oh, you were actually storing like some version of a Roman numeral in there or something. So I don't know why anyone would ever store Roman numerals like this. I did come up with a nice contrived example. So because I have movie titles, you're not going to believe, but it's true, there's a movie in this fake data, I should say, called Rocky War. So let's say Rocky War had a bunch of, movies that came out afterwards, because once you have one good movie, then you have to have at least 3 bad sequels. So let's say they put in a bunch more Rocky War movies, and they have to have Roman numerals because they're movies, right? Like, you have to do Roman numerals. I can now select title from film down here where the title, so that little squiggly is just like I'm doing a regular expression, so it will match anything that says Rocky War. And you can see there's actually 4 matches in there. And I'm actually going somewhere with this. I know you're kind of like, why is he still talking about Roman numerals? But, so one thing you will note is that this has actually just pulled the data back in like a text ordering. But with toNumber and Roman numerals, right, if I were to sort what I had there, and I said, I'd like to see which movies are in order. So I don't know how many of you are, like when movies come out and you're like, I have to see the first one before I see the second one. Right? Or like, I want to see them in order, and then you get in a fight with your friends about, well, do you mean the order that they came out with, or do you mean the order that like they're supposed to be in the series? Maybe I've spent too much time at the bar, I don't know. So if I were to say, order this by 1, you would look at this and say, well, hold on now, the 4th item here, Rocky War VI, that's actually 6. So really, and this one, IX is 9, so these are really not in the right order. Right, if you were trying to sort it based on the number of the title. But with my magic toNumber, right, I can now pull whatever the Roman numeral is out of that movie title and pass that in, and I can sort it. Oh no, I can't copy paste correctly. Sorry about that. It was a long one. All right. So if I run this and I do the actual sort, and of course I have to say nulls first, like programmers, you have to remember everything, right? So here we are, where the title is like Rocky War, and I pass it in to the Roman numeral, and then I sort it, and it sorts the Roman numerals in the proper order. And I know you're all like, dude, I don't have to go to China to find people who don't use Roman numerals. But there it is. If you find Roman numerals in your data, you can now sort them. And that's a reason to upgrade to Postgres 18, if anything is. So that's my opinion. We had a couple other helper functions that are actually more helpful. These are built-in array sorting and array reversing functions. Again, these kind of do exactly what you would think they would do. I have a few examples here we will pull out. And there are too many examples. I need to actually expand this a little bit so you can see it all, which means I'm sort of hiding it, but I think you can see it there. So the first one is I have these fields in the database. So when you have a movie, right, there's features to a movie. So like when you buy the DVD, right, because again, this is old school. So you buy the DVD and maybe it has commentary on it, or maybe it has like deleted scenes, right, or director's cut or whatever. So you can have all these different features on there. So you could actually sort those if you wanted to. Like maybe you're trying to display a list and you want to make it easy for people to look through. Right now, I think there is actually some pattern to the data that is in the database, and I don't know what it is. It wasn't done on purpose. But if I do something like array sort, it will sort these in the right order. If I do the other one, which is array reverse, I think the best one to look at is probably, hold on. I think this one maybe, right? Behind the scenes, if you actually sort this in alphabetical order, it should be behind the scenes first and then trailers. And if you reverse it, it would actually be the same thing, right? Because behind the scenes should go in that order. This one is also good because it just has so many options. Although again, it's a little bit hard to see. But we've got trailers, commentaries, right, behind the scenes. So this will sort it in alphabetical order if you want to do that. Or you can reverse the array. This is a very like sort of visual example, so you can kind of see what's going on here. But obviously it will work for any other kind of array. So if you've ever tried to work out, you know, you've got an array of like numbers or whatever, and you just want to write something, you don't have to write it in PGSQL and be like, wow, that's super slow. Now we have it built in. I don't know how I'm doing on time. It seems nobody else cared about time, so maybe I don't have to care about time. So I'll just keep going. Let's try this one. So this is copy rejections. So if any of you have done like copy command and then, you know, like you got like 10,000 lines of data, and of course there's like one bad piece of data in all that, and then it blows up your whole copy command, and you think like, geez, Postgres, couldn't you have a way to deal with that? Well, now we have a way to deal with that. So I'm going to take a new table called film import, right? It's pretty simple. We got the film ID, the title of the film, and then the rental rate, so how much it will cost to rent that film. And I'm going to do this copy. Now, this is not into the table. This is out to make a CSV file. So I need a CSV file to actually copy back into the data. So I'm just kind of making this one up. But what I want you to note is I'm making it up, and I'm making it up with invalid data to make sure that like you can actually see how this works. So these two lines, the ones that are dash dash invalid, those are the invalid data. And mostly because, let's see, so we've got a number that's written as a number. No, I guess it's written as words as opposed to being an actual number. And then the other one, oh yes, we used Roman numerals because, you know, that's the hot thing now. Almost as much as AI. AI is a little more popular than Roman numerals, but Roman numerals, they're making a comeback. Okay, so I've made a temp file. It didn't even complain. I'm going to use this little bit here. So this backslash exclamation point and then cat. So I'm using the Unix command cat, and backslash exclamation point says run this on the command line. And then out to my CSV, which allows me to verify it did actually get created. So if you ever wondered, like, hey, can I just run random, you know, commands through PSQL that are on the file system? Like, you can do that, but it does do it locally on your file system, not on the server. So just be aware of that. And now I can actually copy this in, and I'm going to give it a few bits of information. So I'm copying into the film import table, right, that I just created. And from my CSV file, and then I have to add in the conditioners, right, the formatted CSV, the header, and then I'm using the new magic, which is this on error ignore. So if you see an error in the copy data, just ignore that, put the data in anyways. And then I have a rejection limit of 2. So if I got more than 2 rejections, I should actually bail out so that way we would finish on time. So, and you see when I run it, it gives me this notice back. It says 2 rows were skipped due to data type incompatibility, and it copied 3 rows of data. So now we have 3 rows of data in there, and if you actually want to see them, I can run it, and we got all 8s, which I'm pretty sure was not what I was supposed to get. But the man in the back says I'm out of time, so I'm not going to actually debug that. You'll have to figure that one out on your own. Pay no attention to the fact that it seems like I got the wrong data on that last one. Oh, select 8 for, thank you. That's why Bruce is on the core team. That's totally it, yes. I missed the shift button. That's how demos work. So in case you thought I was like, this is all scripted, it's totally not scripted. Select all, yes, now my data is actually there. Okay, great. All right, so they say I'm out of time, so thank you all for bearing with me. Hope you've seen some new stuff here. And again, if you want to get the file and download it and play with it, please do so. And again, thank you very much. We'll see you tomorrow, I guess. I don't know. I don't know what we're doing. All right, thanks.